In this video, we're going to look at some intermediate level questions for number properties on the GRE. And I flagged the ones that I want to talk about in this problem set here. By all means, take a screenshot, attempt these on your own, but let's just go relatively quickly through them. Which is greater, absolute value of 6 or absolute value of -7? Again, remember, absolute value is asking how far away is the number inside from 0. So clearly, -7 is further away from 0 than +6. So the answer is going to be this one. Oh, yeah. I have to stop myself because I just want to nerd out on this more. Maybe, let me know if it would be valuable to make some videos on absolute value. I probably will, regardless. But, yeah. Okay, so that's the answer there. -7 is further away from 0 than +6. So we're done with that one. 13, sum of 4 odd numbers. I flagged this one because this is a good thing to do here. Anytime that you have questions involving odd or even numbers, you can just pick some examples, plug it in, see what happens. Odds and evens have the property of, mathematically, that no matter what numbers you pick, whatever you come up with is going to work. So what I mean by that is, if we're asked to find, will the value of the sum of 4 odd numbers be odd or even, just pick 4 random odd numbers. Just 1. How about that? 1 plus 1 plus 1 plus 1. Okay? What do we get? 4. It's even. We're done. That's it. Just to verify this, just to show you for you doubters out there. Supposing we just pick completely random odd numbers. 3 plus 57 plus 9 plus 11. Pull up my calculator for this one. Where is it? There we go. Okay, look what happens. 3 plus 57 plus 9 plus 11, 80. Even. We're done. Okay? Questions about odd and even integers on the test are easy points. Just pick some random odds or evens, depending on what they tell you to do, and do it. In this case, add them up and see what you get. Done on that one. 14. Same thing. Product of 2 even numbers multiplied by 1 odd number. Well, let's just make something up. How about 2 evens? 2 times 2, and let's do an odd number, times 1. What do we get? 2 times 2 is 4, times 1 is 4, even. We're done. I'm just going to move on. You can test this with other possible number combinations, but that's it. It's going to be even. So what about 15? This one. What is the greatest number that is smaller than 153, but is divisible by both 3 and 7? The reason I flagged this one is I want to just talk about this. If we're told that a number is divisible by 2 things, well, the first thing you do is, if it's divisible by 3 and 7, so we got some sort of unknown number, we have to, in some way, be able to divide it by both 7 and 3. Well, you can think about this. That means 3 times that means the number has to be divisible by 21. Just pause the video for a moment and cogitate that for a minute. If we can be divisible, we have to be divisible by both 3 and 7. We have to be divisible by 3 times 7, because ultimately that's what factors are, right? We're multiplying all these numbers together to make something else. So, I feel like that didn't make a lot of sense. Please just roast me in the comments, okay? If this is just absurd. But here we go. So we know that we have to be divisible by 21. Well, that helps us figure out what number we can do, because it's relatively easy to count multiples of 21, right? We need to do the biggest thing that can be divided by 21 that's smaller than 153. So let's do this. So 21, 42, oh gosh, I'm just going to use the calculator. Okay, 42. So how about 21 times 3? That gets us to 63 is another possibility. And what else do we have? I don't know, I have two calculators out. There we go. How about 21 times 4? Should be what, 84? Yeah, 84. 21 times. I have a feeling, I have a gut hunch. I think it's going to be 6. Let's just see. 21 times 6 is 126. How about 21 times 7? We just need some 140. Yeah, that's it. There it is. 147. You know, again, the idea being that you identify, and again, this is so key on the GRE. It's not really the computation. It's more of understanding what we're looking for. So with this question right here, we knew that we had to find something that could be divided by 21, and we wanted the biggest possible number that could be divided by 21 that is smaller than 153. And I know some of you math nerds out there are going to like hit me with here, like, yeah, you could have done a modulo 150. Yes, you could. Yes, you could. Okay, but for the rest of us, just keep your mathy, geekiness to yourself. But okay, again, let me know if this did not make sense, and I will be more than happy to go over this. Okay, let's jump through the last couple of questions here before this gets ridiculously long. Let me clear this out a little bit. Okay, here we go. All right, let's look at this one. 16. The sum of a set of 3 consecutive even integers. Now, this is something that pops up, the idea of consecutive integers or numbers, I'll just put. Now, the idea here is that means consecutive just means in a list. So if you think about numbers, right, we've got 1, then 2, then 3, then 4, then 5, to, whatever. These would all be consecutive. Now, so if I said I had a list of 3 consecutive numbers, what we would need to know is what number we started with, right? So if I started with 3, and I had 3 consecutive numbers starting with 3, well, the first number will be 3, the next will be 4, the next will be 5. What you need to think about is what's the pattern? And there's only a couple different types. If I just tell you straight up consecutive numbers, there's 3 types. I could say consecutive, I'll say consecutive numbers. There's a pattern for this. Consecutive odd numbers or consecutive even numbers. Let's think what the patterns are. Just consecutive numbers. Let's say I had 1, 2, 3. Think about what this is. Well, given what I started with, let's say that's x. I don't know what it is. But the next number is just going to be 1 bigger than that. So that the next number would just be x plus 1, right? And then the third number would just be 1 bigger than that. So that would just be x plus 2. That's the pattern for consecutive numbers. Okay? Whatever we start with, just the next one is just 1 bigger, so just add 1 to that. And the next one after that, well, that's just 2 bigger, so just add 2 to the, whatever our original number was. But then look at this one, consecutive odd. So supposing I told you I have a series of 5 consecutive odd integers. Let's write that down just for a moment. Let's just make a pattern here. So I'm gonna make a list of 5 odd numbers in consecutive sequence, and let's see if we can see what the pattern will be. So supposing I started with 3. The next one would be 5, and then 7, and then 9, and then 11, and then 13. Okay, what's the pattern here? Given what we started with, which supposing we didn't know what that was, put down over here, let's call it x. I didn't know what my first number would be. But the pattern is it increases by 2 every time, right? To to go from 3 to the next on, I have to add 2, then add 2, then add 2, then add 2, and so on and so forth. So my list would look something like this. Whatever I started with, then the next one is 2 bigger, and the next one is 2 bigger than that, and the next one is 2 bigger than that, and so on and so forth. Hopefully that makes sense. Same thing with evens. I'm not even going to work all this out. Roast me in the comments if this doesn't make sense. But supposing we started with an even number. Say I started with, 16. What's the next one? Well, that's going to be 18, and then 20, and then 22, and then 24, and so on and so forth. But it's still the same pattern of, given what I started with, the next number is going to be 2 larger, and the next one's 2 larger than that, and so on, and so on. So the pattern there is the same. Both of these, if we have consecutive odd or even, we know it's always, whatever we started with, every other term is 2 bigger. So look at this one. Let's just try 16. I know this is getting really long. We might not get through 17 and 20, but I definitely want to work out 16. Look at this. The sum of 3 consecutive integers is 102. What is the sum of the 3 consecutive odd integers that precede the lowest number in that set? Well, let's figure out what would be the lowest number. So we have some unknown first integer, then the next one is 2 bigger, and the third one would be 4 bigger. So if they said the sum of these is 102, well, let's add all those things up, right? So what's x plus 2 plus x plus 4? That gets us to 3x plus 6 has to be equal to 102. I strongly encourage you to pause the video if this was confusing to you. Okay? But then we can just solve from there. 3x plus 6. We can subtract 6 on both sides. That gets us to 3x is equal to, what is this, 96. Divide that both sides by 3. That gets us to 3 is equal to 32. X is equal to 32. So those would be our 3 consecutive even integers. 32, 34, 36. Done. But then what do we have here? They asked, what are the 3 consecutive odd integers that precede the lowest number in that set? So we want to know, well, what would be the 3 odd integers behind 32? Well, the first one would be 31, the second one would be 29, and the third one would be 27, right? And if we add all those up, what is this going to get us to? Oh gosh, let's see. 27 plus 29 plus 31. Whoops. Oh gosh. Sorry, I messed that up. Okay, try to. Yeah. Okay, this video is running a little bit long, but and my calculator died on me. So all you would do is just add up those 3 numbers right there, and that would be your answer. Okay, I'm going to pause here. I will continue later on, but hopefully this was helpful.